Pyzdek Institute.
This is a lesson from the first lesson actually from our Lean Six Sigma Black Belt training, and it presents the Lean Six Sigma DMAIC process at first at a high level. I like to consider it like 10,000 feet, and then we drill down into that process so that we see it in a lot more granular detail. What I found is that a lot of Six Sigma Black Belts find themselves stuck in later phases of the process because they fail to do all the steps up front. So I have used this approach for a number of years and on many different projects, and I think you're going to find that it's a good way of getting the job done. So for those of you who haven't seen it, I'm going to be using something called an LMAP. And an LMAP is just a way of drilling down to an actionable level of detail from a high level of detail. It often helps at the very top level to really get an understanding of what you're trying to accomplish and then take each of those steps in turn. So the Lean Six Sigma process called DMAIC, it of course consists of defining the project, validating the measurement system, which we call measure, and at that same time getting a baseline, so looking at your historical data. Then we go to analyze, and what analyze is all about is identifying the drivers that move the response variable that we're interested in with the project. Then we do improvement, and in this phase we evaluate several different improvement strategies and try to choose the best one. And finally, we make our improvements permanent in the control phase. So this is DMAIC at the highest level. Now let's drill down in the define step. So first of all, in the define step, we need to recognize an opportunity for the organization. Many Six Sigma projects don't address important opportunities, so you need to work with your leaders and your sponsors and be sure that you have a project that's tightly linked to the organization's overall goals and objectives. Next thing we need to do is right-size the project. What you're going to get from your leaders are very, very high-level project objectives. And you're going to find as a change agent in the trenches that the projects will be too big. You need to develop the scope of the project and to such an extent that you can actually finish it in a reasonable period of time, and then you have a good chance of success. The next thing you need to do is develop a project plan. By the way, the Goldilocks, of course, not too big and not too small, so you need to actually work on getting a project that's just the right size. Then we're going to develop a project plan, and of course that's a set of action steps that need to be taken to go from your current state to the desired future state where your project has achieved its goals. Next, we're going to map the high-level process. And in this early stage, what we're going to do is something very much like we're doing here with the drill down. We're going to start with an LMAP of the process and look at what the process is supposed to do without too much detail, without too many loops. We're next going to obtain the voice of the customer and identify the drivers that will move us towards what the customers want. So the drivers in Six Sigma are called CTQs. That stands for critical to quality. And in this context, we're talking about the quality of the drivers in terms of having an impact on the outcome of your project. Next, we validate the measurement system and get the baseline. And there's going to be a twist that I'll show you in this later on, but essentially what we need to start with is an understanding of variation. Variation is an important concept, and Six Sigma focuses on variation, but you're going to find that most of your leaders don't have the proper understanding of this, and your team won't either. So you have to give them a little bit of a tutorial in the types of variation and the fact that variation exists actually. Now we're going to get the process baseline. And by that, I mean we're going to look at historical data and that's relevant to your project to see what the project is doing before your project. So it's very hard to measure improvement if you don't know where you started from. Then you're going to stratify the data, so you're going to break the data down into pieces. This drill down process is going to help you better understand your root causes of variation, and then set goals for the outputs. So at this point, you've got a baseline. You know what the process has been doing historically. You've got a feel for what the different categories of variation are, and you can set goals in terms of what your project's going to accomplish. Next, we're in the analyze phase, and we're going to focus the problem statement further. Then we're going to develop theories of cause and effect. So there are two different ways of thinking. One is analysis, and the other is divergence. So in the divergence phase, we're going to bring as many theories under consideration as we can get, and we're going to test those theories at a later phase. So we need data. That's one of the defining principles of Six Sigma. It makes it different from other things, is that we're going to test our theories. We're not just going to accept them at face value. Next, we're going to build models of cause and effect, and these are going to tell us how the X's or causes, root causes, relate to the Y's, which are the response variables that we're trying to change with the process, the opportunity we're trying to address. Then we're going to identify improvements. Once we have our models of cause and effect, we can look at the different X's and we can assess the cost of changing them and look at their impact on our outcomes. And we'll find the process improvements that cost the least and give us the most bang for the buck. So we'll do a cost benefit analysis. Black belts do learn some rudimentary tools for this, but you probably need some help from your finance people. Now we're going to set improvement goals for the X's. The critical to CTX is critical to cost, critical to schedule, critical to quality. So we're going to set our improvement goals at the cause side of the equation, and we'll have the model that will tell us that we should reach our goals if we do that. Now we're going to develop improvement plans, and these are plans for implementing the changes that we need. We're going to assess the risk. Change involves risk. We want to be sure that we've contained the risk and at least shielded our stakeholders from too much negative impact. We're going to develop contingency plans. Not all plans work as they're supposed to, and we want to have a plan B in the bag just in case. To make our improvements permanent, we're going to change things like standard operating procedures and policies. We're going to implement the changes on a full scale, and we're going to transfer ownership of the new process. Finally, we're going to follow up and see that the benefits that we predicted actually occur. So if you back up from this and take a look at it, maybe pin it on a bulletin board and stand back, this is your framework for achieving process excellence. So basically what we're saying is that if you execute these steps and you do them well, you will actually improve your process performance and make things better than they were. So next we're going to drill down on each of the steps under the define phase. So this is an L2 map, level 2. And under recognize the opportunity, well, what does that mean? I was once told by Phil Crosby that the people that work in the quality profession have a habit of telling leaders that they want their support without specifically telling the leaders what we want them to do. So these steps, the L2 step, is going to break down these broad statements into something more meaningful. So recognize an opportunity. What does that mean? Well, first of all, it means we know what the leader's vision is and we know what the opportunities are. And this needs to come from the leadership of your organization. If it's not done formally, you'll need to talk to the business leaders to see what's on their mind. You need to meet with sponsors and see what's on the sponsor's mind. So a sponsor will be an executive that has the ear of the leaders and knows something about what the leaders want and what their opportunities are. So ideally, the leaders will look at their highest level goals for each stakeholder, and they'll look at where they're falling short, and they'll then identify sponsors who can address these shortcomings, and you'll then work with these sponsors. Next, you need to do a Pareto analysis. And I'm not introducing Pareto analysis as a tool so much as a concept. So what the Pareto concept involves is the 80-20 rule. Take a look at the major problems that you're having that are part of the opportunity you're trying to address, and look at the biggest drivers. Be sure that you're addressing a major driver and not something that's not very, very big in terms of impact. Then you need to do a feasibility analysis. So a feasibility analysis will help you identify whether or not your project is addressing an important opportunity, if it has sponsorship support, if you have the resources that you need, if it's the right size, and so on. Now, start your project planning with a charter. Charter is something that you and the sponsor will work together to produce, and it's going to have a series of major components, such as what is the project, what's the problem we're addressing, and timelines and team members and so on. Then select your team and do this in conjunction with your sponsor. You'll have to be familiar with team dynamics. Small groups go through certain phases, and they have to become effective as a process. So for those of you who follow basketball, this is the time when teams go into tournaments. You'll hear a lot of talk about teamwork. So you have the individual members of the team and certainly their talents, but you have to blend them together in a workable team. Have a kickoff meeting with your sponsor and tell the team what the project's all about and why it's important. Next, look at the stakeholders, who's going to be impacted by your project, and make a plan for getting stakeholder support and keeping your stakeholders up to date with your progress. Then you're going to do the traditional project management and scheduling. So if you're a certified project manager, you know that there's a toolkit involved here. Six Sigma uses a subset of those tools. You'll run into barriers as you do the project. The best strategy for dealing with the barriers is to identify them in advance and avoid them. And by avoid, I don't mean just ignore, but I mean find a way to execute your project that doesn't encounter the barriers. For the barriers that can't be avoided, you'll have to have a strategy for overcoming the barriers. And there are tools to help you do this, such as a force field analysis. And actually, failure mode and effect analysis is sometimes useful here. Finally, have a communication plan as your project progresses. Keep all the stakeholders, team members, and sponsors up to date. And this will include milestone reviews that are formal, but also a lot of informal means. You might want to develop a social networking tool for this. You might want to use internet or intranet pages, email, SharePoint. There are a variety of tools out there. But the important thing is to have a plan and to execute it. Next, we're going to map the high-level process. We're going to start with LMAPs like the one you see here. Also, maps we call SIPOC maps. The S is for suppliers, I is for input, P is for process, O is for outputs, and C is for customers. So basically, it's a supplier to customer map that shows the major components of the process. The Lean tool of product family matrix is something very useful. So you can design your project so that it impacts a number of different products or services that your organization produces, and thereby leverages the work that you're going to be doing. VOC analysis, voice of the customer. That's a tricky, it's more complicated than it sounds. First of all, obviously, we're going to talk to customers. And also, we're going to take what the customers tell us, and we're going to do what's called a Kano analysis, which basically looks at what are the basic quality characteristics, what are customers actually explicitly looking at, and what can we do to excite them. And the exciting quality is something that you probably will not obtain by talking to customers, because you really want to surprise the customer with something that they didn't expect. There's a tool called a tree diagram that's very useful, and a tree diagram helps you drill down from the why or output that the project is trying to produce to the critical drivers of that output. Then you're going to look at the critical to quality specs. So these are the root causes and the drivers that, to the best of your knowledge, you've identified at this level, and try to see what level they should be set at based on your historical data. Finally, after each of these major phases, you should do a toll gate review. Sit down with your sponsor and your team and look at what the project has accomplished and make sure that it's still moving in the right direction. So if you pin this up on your whiteboard, basically what it tells you is what you need to do to complete the project successfully before the project is actually too far along. So next we're going to validate the measurement system, and I'm going to explain why the second chevron is a shade of gray. So first of all, there are some principles of variation. One is validity, which means that you measure what you think you're measuring, and that sounds obvious, but it's not. Quite a few times we'll find that we're measuring some surrogate that we think has a direct relationship to the thing that we're interested in, but it doesn't. So you actually have to explicitly think about this. Next, reliability. That simply means that different people taking measurements of the same thing will produce the same results. Look at the measurement scales. There are scales that are more sensitive and contain more information than others. So an attribute scale, a go, no-go scale, has a minimal amount of information, whereas a continuous measurement has a great deal more information. And there are usually pros and cons and reasons for choosing a measurement scale. Data types are somewhat related to measurement scales. There are attributes data, continuous data, and give some consideration as to what type of data you're actually using. There are also different kinds of studies. One kind of study is called an enumerative study. This is what we learn about in college, and it basically involves looking at static populations and trying to estimate parameters. Analytic studies are different. There we're not looking at populations, we're looking at dynamic processes, and we're not so much interested in estimating parameters as we are in predicting the future performance of a dynamic process. People need to understand the idea of statistical control, that there is variation due to special causes and variation due to common causes, and that these types of variation are different and they demand different approaches from management. Anything you're measuring needs to be operationally defined. That means it needs to be defined in real plain language, and it also needs to have a measurement associated with it. Next, in a project, we analyze the measurement system. The reason this is grayed out is that while we do it at this point in the project, this is not where you should teach it. The reason is that measurement system analysis is a designed experiment, and the tools that you need to do a designed experiment aren't really taught to Six Sigma belts until the analyze phase. So for teaching purposes, we're going to do this later, but once the training is done, this is the point where you'll do it in the project. So we have continuous data measurement system analysis and discrete data measurement system analysis. Continuous measurement is a measurement such as time. A discrete one would be a discrete measurement might be where you break time into discrete increments and you say, old, middle-aged, and young. And I won't tell you which category I belong to. We typically have always done continuous data measurement system analysis, but it's important to look at discrete measurement systems too. So if you have people that say looking for errors on an insurance claim, you may be surprised to find that different people looking at the same claim will define error differently, and that would be an indication of a measurement system problem that you'd want to identify at this stage. So now we're going to establish the process baseline, And this is the first place where I start introducing statistical tools in training. So we start with descriptive statistics. What is the process doing? What's its central tendency? What's its spread? Are there outliers, extreme values, and so on? We're going to want to look at the data over time. So we're going to put it on a control chart and use SPC tools to identify special and common cause variation. And as I say, they are addressed differently. We're going to consider distributions of the things that we measure. That distributions include central tendency, spread, shape, and so on. Next, we're going to look at the capability of the current process. So what can the current process do? And often what we'll find in a project is that the act of doing the definition and putting the data on charts improves the process to the point where we're done here. So you may be lucky and find that that's the case. If not, you'll at least know how much improvement you need to make in the process. There's another way of measuring the baseline, and it's called rolled throughput yield. Rolled throughput yield is a way of looking at multiple processes and combining them to determine the yield of the combination or set of processes or set of process steps. There's a statistic that's commonly used in Six Sigma called process sigma, and basically what that is we take the rolled throughput yield number and we convert it to a sigma level, which tells us that on a normal curve, this sigma level would correspond to the rolled throughput yield. One of the advantages of a process sigma metric is that you can compare processes that use different metrics. So it's a way of looking at and comparing multiple processes with one another. You'll also want to create a current state activity map, sometimes called an as-is map. This is basically a flow chart showing how the process is currently done. If you're doing lean, you want to create a current state value stream map. And this will show, if you're just starting lean, it'll probably show a process that uses a system called push. Push systems look a lot different than lean systems, which are called pull. And you're going to want to use this process, the current state value stream map, to help you identify improvements. Another lean tool is the spaghetti diagram, and this measures the physical movement of product or processes. It can also be used to just show a flow from person to person or station to station in a service or healthcare process. In stratified data, we're going to begin by looking at how to collect data and how to sample. So this is a set of tools to help assure that your data is useful after you've collected it. We're going to use Pareto analysis again. This time we're going to look at breaking down the causes to determine which ones have the most impact. The first time we did Pareto analysis, it was to look at the problems and be sure we're addressing the problem that has the most impact. Tree diagrams are a way of stratifying the data and looking at the different pieces. So for example, if you're looking at sales as the variable that you want to improve, sales consist of the number of prospects who have been approached, the number of deals that have been made, and the price per sale. So breaking it down, then you can look at the details and get closer to the root causes. XY matrices help you relate causes, which are called X's, with effects, which are called Y's. And again, the whole point of Six Sigma is to identify cause and effect and to deal with the causes instead of the effects. Well, deal with the causes and thereby deal with the effects. Check sheets, a useful little tool to just show you where the problems are coming from, and you can create check sheets that actually show you patterns and distributions as well. Histograms are a little more detailed. They're group frequency analysis. By that I mean that they show a distribution, an empirical distribution based on actual measurements. Stratified frequency plots, you'll break down the data according to its source. So it's kind of a combination of a tree diagram and a histogram in a way. So you're going to look at the different sources of variation, and you're going to look at what the measurements are on those variables. There's another tool called exploratory data analysis, and the purpose of exploratory data analysis is to help you identify possible causes and explanations without actually trying to prove a hypothesis. Set the goals for the outputs. We're going to use a tool called a prioritization matrix, and that's simply going to help you, as the name suggests, prioritize which process steps or which critical causes you're going to address. So in all likelihood, you won't have the time or resources to address everything, and this is going to help you determine what to address. You're going to use benchmarking, which means going outside of your process and outside of your organization to find the best-in-class performers. So find the companies, organizations, or people who do what you're trying to do very, very well, and use the information that you get to help you improve. Failure mode and effect analysis is going to help you by showing all of the different ways which your process can fail and what effect it'll have if it fails, and what you can do to mitigate those problems and hopefully eliminate them. So now you've got the information you need to answer these questions. Next, we're going to the analyze phase. We're going to start by focusing the problem statement. We're going to use something called an opportunity map. And what that is, an opportunity map is simply a activity map that shows value and non-value added steps. And you're going to, of course, attempt to eliminate as much non-value added work as you can. The future state value stream map is another way of focusing your problem statement. So you're doing lean, you've got the current state value stream map. You're going to look at where you can eliminate inventory and process steps and streamline the value stream. And that will be something you could then draw out on paper in a future state value stream map. Next, you're going to select the part of the value stream where you're going to focus your project's attention, and you're going to identify the high impact variables in that area, which is called a loop. Now we're going to do divergent thinking. So we're going to try to put as many thoughts on the table as we can, and brainstorming is one of the tools for doing this. Basically, it consists of a group of folks sitting around, letting their minds soar and using their imagination to determine as much as they can about how they might improve things. Affinity diagrams are ways of categorizing and grouping the brainstorming output. Probably one of the categories will be, ignore this, because a good brainstorming question will generate a lot of silly ideas. But these silly ideas may inspire some truly significant breakthroughs, and hopefully, your affinity diagram is going to have some useful categories that will help you focus. Fishbone diagrams can be used to organize the affinity diagram output into a graphical format. A fishbone diagram is called that because it looks like the skeleton of a fish. The head of the fish is the problem that's under consideration, and the little bones are the causes of the problems. There's a formal method called root cause analysis that was developed by NASA that will help you drill down to root causes. Next, we're going to test the theories with data. So again, one of the hallmarks of Six Sigma is that we don't stop with the theory and assume that it's true. We're going to collect some data. We're going to use statistical inference to test some hypotheses. So hypotheses are statements regarding either a state of nature, this is what the process looks like right now, this is what it is, or it involves a hypothesis about cause and effect. So if I change X by this much, I will see a change in Y. So we're going to test all of our assumptions with data. And basically, we're going to teach a set of statistical tools for doing that. There are two categories of tools. One category is called parametric, and parametric tools assume certain parameters, such as the distribution is normal, but there's another set called non-parametric, And that's useful if the assumptions are not borne out. So if your assumptions are violated for your statistical test, you may look at non-parametric methods as a way of still testing your data rigorously. Now we're going to model cause and effect. So you have to learn what modeling is and how it works. You're going to first begin by doing correlation analysis and creating scatter plots. Correlation analysis essentially just looks at the association of different x variables with one another or with y's. So you're going to say, you know, as this x increases, this y tends to also increase. This is not necessarily a proof of cause and effect, but it's at least an identification of a possible relationship. Linear regression is a tool. It simply fits a straight line to some observed data. So as I vary x over a certain range, if I do regression, it'll tell me that a change in x of a certain amount leads to a change in y of a certain amount. Then I'm going to do diagnostics, and essentially that's a test to see if my model actually is any good. And then I'll do prospective analysis. So what we've done up to this point, the first 4 steps, is we've looked at historical information. And that's nice for developing hypotheses. But for really testing your hypotheses, experiments should be designed to help you really understand the relationships that you see. If you're working on a lean project, this is the point where you actually start doing your preliminary cell design. So how are you going to organize the work in the workplace? Next, we're going to quantify the cost of the improvements. And of course, we're going to look at cost-benefit analysis, prioritize the different improvements in order of their cost-benefit, do a risk assessment and another failure mode and effect analysis now that we know what we're going to be changing. And this is going to tell you why outputs vary and how to use that information to make your process better. So at this point, we've taught all the statistics we need to do to teach measurement systems analysis. So in a training course, this is where I would recommend you teach MSA. Now we're going to go to the improve phase. We're going to create CTX goals with an XY matrix. So what that means is, now that we know what the critical drivers are and we actually have models of cause and effect that are mathematical, we can set our goals. An XY matrix is simply going to show you that as I change these X's, it'll have impacts on these Y's, and here's the kind of impact we think it's going to have. We'll set the benchmark or goal for the different X and Y variables. We're going to standardize the work. We're going to generate plans, and the plans are going to have a sufficient degree of detail that we can conduct pilots. We're going to choose the best plan. One of the tools that we teach is called the Pew matrix for selecting plans and comparing different alternatives. And at this point, you may want to restructure your team. The reason I say that is, up to this point, we've been conducting a DMAIC project: define, measure, analyze, improve, and control. But once you've done define, measure, and analyze, and you've developed an improvement plan, this now becomes a just do project. So you now know what you're going to do, and oftentimes the team that is best suited for the first part of your Six Sigma project is not the team that's best suited for the implementation phase. So you may want to reconsider the team membership, make this into a just do project, and move on. So we're going to do a pilot. You can do this pilot if you're doing a design for Six Sigma and you don't actually have a real process yet. The pilot might be a simulation, or it might just be walking through the steps or doing it in a limited area. Some way to learn and assess the damages. So in the, use the basketball metaphor again, it might be like a scrimmage. From your pilot, you'll get some data and see if things work the way you were supposed to. So you set the variables where the designed experiment said they should be set, and did it work? Now recalculate the cost of improvements. So again, you had estimates. Now you've got some real data, and see if your cost benefits analysis has changed. If necessary, revise the plan. And this is an iterative process. So steps 1 through 4, each cycle through that is a learning step, and you go through those until you're ready to move on to full-scale implementation. Now develop contingency plans. What happens if things don't work according to plan? This is a PDPC, Process Decision Program Chart, is a tree diagram that basically looks at possible ways your plan might fail and what you're going to do to address those paths. So finally, we reach the control phase, going to develop new procedures, implement the full-scale changes, transfer the ownership to the new process owner, and follow up to validate the benefits. So the organization has things that make it difficult to change. And as a change agent, you'll find these things to be challenging. But these are also potentially good things, because what you'll find is that in the control phase, you can use these things to your advantage to keep from backsliding and going backwards to the old way of doing things. Your control plan will include things that were identified on your your PDCA analysis, which is Plan, Do, Check, Act, which, by the way, is something that supposedly was invented by Dr. Deming, but Dr. Deming, his system is called Plan, Do, Study, Act, and he kind of disavows PDCA, although to the untrained eye, there's not much difference. Use things like the lessons that you learned from your failure mode and effects analysis, from your mistake proofing analysis, from your SBC analysis, and so on, to lock in the improvements that you've made. Lean tools such as 5S and the visual workplace should be implemented here. Next, do a project planning review. Look at your project in retrospect. Develop a deployment map and plan. So that's basically an activity map with swim lanes, and the swim lanes are just categories showing who's going to be responsible for the different activities, who may be a department or maybe an individual. Look at the training needs. Now that you've changed the process and made it different, people may not have the skills they need to operate it. So you have to look at what's needed in terms of teaching the new process owner and operators to use the new process effectively, and deploy it, put the changes into effect. So this is where the rubber actually meets the road. Transfer ownership to the new process owner. It probably won't be your sponsor, but it'll be someone who's responsible for the process as a whole. And this is another new idea with Six Sigma, because prior to Six Sigma, we looked at functions. We looked at organizations as structural hierarchies. So we had functions such as engineering and sales and so on. Now you're going to have actual processes. So you're going to have owners that are going to be matrixed with the functional leaders. So a process draws resources from several different functional areas, and the process owner will be the one responsible for the process. Develop a dashboard so the process owner knows what to look at to be sure the process you've designed for that owner actually stays on track. And then look at ways to improve. So new process may be better than your old one, but it's always possible to continue improving things. So develop continuous improvement plans. The approach called Kaizen is for looking at current processes and trying to make them even better. Extend the flow from your process, your internal process, upstream to the suppliers of that process and downstream to the customers. So basically look at the inputs and the outputs of your process, and the people who receive the outputs, the people who supply the inputs, and help them do a better job. So follow up Essentially, you're going to look at the dashboard with the new process owner for a while. You're going to validate that you got the return on investment that was forecasted, and you're going to close your project and leverage the lessons learned to other areas. So that pretty much completes your project. And at that point, we will have done toll gate reviews for each of the major steps, and we can now do a project toll gate review. And again, be sure that you update your official documents and the learnings that you've achieved. So at that point, the presentation is completed. And are there any questions?